Okay, today we're in section 5.2, rates and unit rates. There's two reasons why I'm starting off today's lesson. Stop talking. I'm starting off today's lesson with a review slide. One is, when did we learn 5.1 again? Like a week and a half ago. Okay, so it's been a long time since we actually learned this lesson. We need a refresher. Here's the second reason. It directly feeds into what we're doing today. Okay, so with rates and unit rates, we have to understand finding the value of a ratio. And that really was at the heart of 5.1, was finding that value of a ratio that was the same across the entire ratio table, and I could use that value to find the unknown parts. All right, because we remember that from the top number to the bottom number, from the first number to the second number, I'm multiplying or dividing, top to bottom, dividing. Bottom to top, I'm multiplying, all right? Find the value and fill in the missing blanks in your ratio table. Okay, so 10 divided by 4 is what, guys? What's my value of my ratio?
2.5.
2.5, right? Did you find 2.5? Okay, so 2.5 is my value all the way across. So what is, sorry, my iPad's freezing up. What is 18 divided by 2.5? What's 18 divided by 2.5?
7.2.
Okay, so it's 2.5 all the way across for my value. And 18 divided by 2.5 is 7.2. So that's how I find, in order to stick with or create equivalent fractions, I have to use the same value. So I can divide, if I'm moving from the first number to the second number, divide it by the value. What if I'm going second number now up to the first number? What am I going to do with the value? I'm going to multiply 6 times 2.5. And then again, top to bottom, I'm going to divide. All right, and now what I need you to do is pull out your equivalent ratios. Now, there are 3 ways to write a ratio. Tell me, what is it? Use a colon. What's another way to write a ratio? Put it in a fraction. What's another way to write? Use the word 2, okay? It does not matter, and your book mixes it up too. It does not matter how you write the ratio, but you need to pull the ratios out. So you should be doing that. 10 to 4. 18 to 7.2. I use the word 2 on that one. That's okay. I'm still writing the ratio. First value to the second value. 15 over 6. Write it as a fraction. Okay, all of these ways to write a ratio are fine. Okay, so I'm just kind of showing you that using any one of your ways to write a ratio would be fine. But again, for all of these ratios, here's what they have in common. When I divide the first number by the second number, I get 2.5. They all have the same value. Are these the only numbers or the only ratios that I could have come up with in this table? No. There's actually an infinite number of ratios I could create with this value. Do you see that? Okay. And on the open-ended ones, like on your homework assignment, that's kind of what we proved, because the whole thing was open. You could choose whatever number you want. As long as you're using the same value, you create an equivalent ratio. All right? Okay, so that's our 5.1 review. So now let's go over a couple terms, and then we'll get into our examples. All right? So what is the difference between what you're learning today versus what you learned in 5.1? Because truth be told, it's actually pretty similar to what you learned yesterday, or not yesterday, but in 5.1. A rate is a ratio, a comparison of 2 quantities, so far it's the exact same, using different units. So here's where we see the difference between ratios and rates. A rate uses different units. Okay, so the first unit might be cups. The second unit might be tablespoons or grams, or we're going to see all different kinds of units. So here's what's important for this section. You have to label your answers. You have to understand what you're solving for in the first place. All right, and there's an order that we can use. All right, so a unit rate, well, what does a unit mean? 1. So it compares a quantity to 1 unit of another quantity. And equivalent rates, that one's kind of obvious. They have the same unit rate, okay? So just kind of write those down real quick. You could even like kind of summarize it. But those three terms are important. All right, example one. All right, example one, you know they're going to put them in sentences or these like real life scenarios, okay? And that's exactly what we see here. All right, this is straight out of your book, so you do not need to write what's written in bold. Okay, so, but here are my two scenarios. A nutrition label shows that for every quarter cup of tuna, it has 1/2 gram of fat. All right, so here's what I need to find. Here's my first question, and I do need you to write this down. How many grams of fat are there for every cup of tuna? How many grams of fat are there for every cup of tuna? So the order is important because they're saying how much fat. That might not be like per 1 unit. This is what I'm wondering. For every cup of tuna. So that is for every 1 cup of tuna. So here's how I do it. All right, we'll go ahead and write down the question, and then we'll talk about how to set up your unit rate. All right, so we're going to set this up in a ratio, but it's important that we show the labels, okay? So, and we need to write it in the correct order. So how many grams of fat? Which fraction represents fat? 1/2. So it's not in the order that I read it. I've got to start with 1/2. And again, okay, I'm dividing. All right, so I just don't have enough room. Actually, you know, I'm going to write it off to the side. All right, so this is 1/2 divided by how much tuna? 1/4, okay, or 1/4. And when we divide fractions, what we're essentially doing is we're saying 1/2 divided by 1/4. And what happens to my second fraction? I flip it, okay? And then I have to multiply. All right, so now I multiply it by 4/1, which gives me what? 2. But now I have to label. The label is so important. What does this mean? This means 2 grams of fat per cup of tuna. You've got to label. 2 grams fat per, you can say PER, cup of tuna. All right, so that's where the unit rate part of it kind of comes into play. All right, and that whole label is important. So in the past, how many points have you missed for not labeling?
1.
Like 1 or 2. Here, you missed the whole thing. Okay, so unit rate, unless you tell me, now I can kind of see in your work, but unless you tell me in your label, I don't know if you actually understood what unit you were even finding the unit rate for. All right, so that's why unit rate is so important. Now let's look at the second scenario. So I'm going to have to clear this. Do you guys have this written down? Okay, so now let's look at the second scenario. How many cups of tuna now are there for every gram of fat? So really the only difference here is what's happening. I'm switching the order now. Now I'm looking how many cups of tuna can I eat if I only wanted to eat 1 gram of fat. Guys, that's not realistic, okay? Like, you can eat more fat than that and, you know, you're not going to become like, yeah, exactly. I was trying to think of a different word to use for it, but yeah. Okay, go ahead and find the unit rate. Okay, so again, we're just practicing how to find the unit rate. Whatever that second unit is, that's usually the unit rate that we're looking for. All right, let's set up our fraction. All right, so how many cups of tuna? So which fraction represents tuna? 1/4 divided by 1/2. And we know that that's technically 1/4 divided by 1/2. And what happens to my second fraction? What happens to my second fraction, guys? I have to flip it and multiply. So now I'm timesing it by 2/1 to get 1/2. But now I have to label. What's my label now?
1/2 cups of tuna every gram of fat.
Yep. 1/2 a cup of tuna per gram of fat. All right, so now I'm going to ask you a question. All right, is everybody listening? So if I said to myself, okay, I think I can manage 3 grams of fat. How much tuna am I going to eat?
1.5 cup.
Very good. So if half a cup is 1 gram of fat, and I said, I think I can do 3 grams of fat, how much tuna can I eat? 1.5, right? I multiplied top and bottom by 3. So you see, that's where equivalent ratios come into play. If you know how much for 1, then if I say I want 5, then I can multiply the top by 5 also. Do you see that? The first quantity by 5 also. So that's where unit rates can really help me. And actually, we're going to see that in example 2. So I'm kind of leading you into example 2. All right, let's answer the second scenario now. All right, so I have to clear the slide again. Again, you don't necessarily have to write what's in bold. That's in your book. How many grams of fat are there? Given the scenario, 1/4 gram of fat for every 1/3 tablespoon of powdered peanut butter. How many grams of fat are there for every tablespoon of the powder? Go ahead and set up your ratio and find your unit rate. Make sure you label. Okay, so we're going grams of fat to tablespoons of peanut butter. So which fraction comes first?
1/4.
Okay, so we're going 1/4. I just don't have a ton of room, so I'm just going to write the division symbol, but we know that that's the first number divided by the second number. 1/4 divided by what? 1/3. And what happens to my second fraction? Okay, I flip it, so this is really 1/4 times 3/1, which gives me 3/4 what?
Grams
Yes. Yes. Grams of fat per. Yeah, there you go. If you know the abbreviation, that's fine. Of peanut butter, powder. You just say powder. Goodness.
Powdered peanut butter?
Yeah, powdered peanut butter. Yeah, there is such a thing.
I'll look it up.
Okay, and remember, guys, the label, pay attention, the label is just as important as your answer, okay, because you're specifically saying, this is my unit rate. So the label makes all the difference, okay? All right, any questions? Any questions? So I found that rate. Okay, so example 2. I'm sorry, before we get to example 2, this is another way that you're going to see these problems, and this is probably a more favorable way that your homework and your quiz and your test will be set up. All right, so instead of it being set up in a scenario, now it's just saying $1.32 for 12 ounces. Whatever this second unit is here, that's what you're finding the unit rate of. Okay, so you're setting it up in a ratio, and then you have to find, okay, well, if it's that much for 12 ounces, how much is it for 1 ounce? And you do that by putting it into a fraction, $1.32 divided by 12 equals, I mean, that's all you do is just divide it. 132 divided by 12 gives me how much money, because this is money. How much is it, guys? 11 cents per ounce. Okay, and you can abbreviate, that's fine. Wait a second, I didn't write the word per. Or did I? The backslash means per. Okay, so you can use a backslash also. All right, so that's how much it is for 1 ounce. I found the unit rate. Go ahead and solve the second one now. All right, so you need work, and again, the label is just as important as your answer, because in the first one, if I had said 0.11 ounces per dollar, if I had those labels mixed up or not put them at all, my reader has no idea what I'm comparing. All right, so the label makes all the difference. It tells us, and it tells our reader what we're actually comparing in the first place. All right, so how do I set up my second one? How do I set it up? I need to show my work. No, that's about the only way you can get it wrong. What is it? 1/4 divided by 3/10. Okay, and technically this is going into a fraction, but I can write a ratio, even 1/4 divided by 3/10. But now what is happening to my second? I've got to flip it and multiply. So now this is 10/3. Okay, so now it's 10 over 12. All right, now, if I said it's 10/12 gallons for every mile, does that really mean a whole lot to me? So, practically speaking, what would be a more practical way to say this? Not necessarily 5/6, but as a decimal value, okay? Now, if you said, guys, if you reduced it to 5/6 and you said 5/6 gallons for every mile, I'm not going to count off for that, but if we're thinking about it practically, probably a decimal value is a little more practical. Now it's a repeating decimal. All right, gallons per mile. Can I let you guys in on something? This is terrible gas mileage. If a car salesman's trying to say it's getting a gallon a mile, you need to tell them no thank you, okay? Yeah, that's terrible. They're supposed to get like 20, 30, actually little smart cars, they get like 50 miles a gallon. Motorcycles, yeah. So this is terrible gas mileage if it's a car. I actually, they didn't give us enough information to know. Okay, any questions? Hold on. Any questions on example 1? All right, now let's do example 2. In example 2, we're using unit rate to solve a problem. All right, so we've got to find the unit rate, and we use that unit rate to solve a problem. You need to write the table. Yes. A scientist estimates that a jet of liquid iron in the Earth's core travels 9 feet for every half an hour. How far does it travel in one day? How far does it travel in one day? So here's where I need to end up. Okay? How far does it travel in a day? So we're going to set up a table. This is how our book sets it up, and I'm okay with setting it up in a table. I don't necessarily think it's absolutely critical that we do it this way, but we can do it this way. All right, so go ahead and set up your table, and then we're going to answer the question. Okay, you have your tables written down? Okay, so we need to figure out what's the value of this ratio. Just like we did in example 1, just like we did in 5.1, what's 9 divided by 1/2?
18.
It is 18. 18 is the value of my ratio. Okay, it's also my unit rate. Okay, that's what we do. The first quantity divided by the second quantity gives me the unit rate. Per what? What is this down here? What is my unit? For time. So what it's saying is, now for 1 hour, that's my value. So how many feet does it go in 1 hour? 18 feet. Guys, let's think about this practically for a minute. If it goes 9 feet in a half an hour, how far does it go in an hour? 18 feet. So now this is where I stopped in example 1. I found my unit rate, 18 feet in 1 hour. But what did it ask me? What did it ask me? In a day, how far it travels. So how many hours are in a day? 24 hours. So that's what goes in my last block. Time, 24. Why did I jump all the way to 24? Because that's what it's asking me. What if it had said half a day? What number would I have put here? 12. Okay. So because of what it's asking me, now I'm using my unit rate to actually solve the problem. It didn't say what's the unit rate, did it? No, but I had to find the unit rate to actually answer the problem. All right, so what was my value again? 18 feet per hour. So how am I going to fill in this top number? Multiply, and what do you get?
432.
Okay, so that's your answer. So you fill it in the table, but now your answer is 432 feet per day. That's how far it travels. Okay, liquid iron. Okay, now read this next question. Please don't blurt out the answer. I want everybody thinking about this question. What if the scientist comes back and states that iron travels 3 feet every 10 minutes? Don't answer it out loud. Does this change your answer of 432 feet per day? All right, don't say it out loud. Think about it, and we'll answer in just a sec. There's a couple ways we can approach this. All right. How many of you say, yes, it does change my answer. It's not going to be 432 anymore. All right. How many say, no, it's not going to change my answer? Okay. So let's think about this. How many minutes are in a half an hour?
30.
Or we can even go to the whole unit. There's 30 minutes. So what would I do to 30 to get down to 10? I would do what? Divide by, not subtracting, divide by 3. So I can do, as long as I can do the same operation to the numerator, 9. What's 9 divided by 3? 3. it doesn't change my ratio. Okay? So another way I could do that is just apply my unit rate also. Okay, I could do that also. And again, my unit rate I'm dividing by 6. And yes, if I do 1 hour divided by 6 to get 10 minutes, and then what's 18 divided by 6? 3 feet, okay? So as long as it's the same value, the ratio, then I'm okay. So this does not change my answer. And my answer is same value of ratio. Same value of the ratio. Okay, and that's my y. Okay? Any questions? All right, example 3. Now we're comparing rates. So here's basically the scenario. You hike up a mountain. What do you think is going to be faster, going up the mountain or going down the mountain? Down. Okay. So realistically speaking, we already know that we're going to go faster going down because we got momentum in our favor, right? But we don't know how much faster. So we need to figure out what is my unit rate going up and what is my unit rate going down, and then I can find the difference. Miles, stop talking. Okay? All right, so you hike up a mountain at a rate of 1/4 mile every 10 minutes. You hike 5 miles every 2 hours on the way down the trail. How much farther do you hike 3 hours on the way down versus 3 hours on the way up? So you have to figure out what's the difference per hour, and then what would you multiply it by? 3, okay? So you have to find the difference in your unit rates per hour, and then we can make it bigger. So that's kind of the overview of where we're going. We need to start first by finding the unit rate of both. Okay, I think I just tried to explain too much without really taking you through it. Okay, so the unit rate of the first one, we've got a problem. They're in different units. Okay, we have this one in minutes and we have this one in hours. Technically, it does not matter which one you go to. Okay. Technically, and I would probably advise that you go down to the smaller of the 2 units. But it doesn't matter as long as you're in the same unit. So how much of an hour, your book goes up to hours. How much of an hour is 10 minutes?
1.6. Like 1 hour.
1/6, right? Because there's 60 minutes in an hour. So here's what I do. I go 1/4 divided by 1/6. I write my ratio, okay, of miles to hours. And 10 minutes is 1/6 of an hour. Well, if I'm dividing the fraction, what do? KFC. Okay. And so then I get 3/2. So basically I'm going 1.5 miles per hour on the way up. Now I have to do it for the way down. So now on the way down, I go 5 miles every 2 hours. So how fast am I going? 5 divided by 2, how fast am I going? 2.5. All right, so and I put going up and going down. Okay, so 5/2 or 2.5 miles every hour going down. All right, think about this. If you're going 1.5 miles on the way up per hour and 2.5 on the way down, what's the difference? How much faster are you going? You're going a mile faster, right? For the same amount of time going up and going down, you only make it up 1.5 miles per hour, but down you're going 2.5 miles an hour. So basically what I'm doing is I'm just subtracting them to say it's 1 mile per hour. But how many hours did it want us to calculate?
3 hours.
3 hours. So I go 3 miles farther. Okay? In the same amount of time, I can go 3 miles farther going down because I'm going faster. Why? Because there's momentum. So that's practical. Okay, you got it? So here's really what you need to take away from example 3. Okay? Find the unit rate of one, find the unit rate of the other, and basically which one's faster, which one's slower, are they equal? That's what your homework's going to ask you is, are they equal? Make sure they're in the same unit before you compare them. All right, and that's everything you need to know for section 5.2.